So in this problem, we need to resolve the given rational fraction into partial fraction. Let us begin. Now what we'll have to do first is we'll consider the denominator, which is 2x raised to the power of 4 plus 3x squared plus 1. So this is a biquadratic polynomial. We'll have to factorize it. We can easily do it by splitting the middle term. So here we have 2 times x raised to the power of 4. So 3x squared can be also expressed as, now the way we can split 3x squared is going to determine the coefficient of x raised to the power of 4, which is 2, and the constant term, so that's 1. So we have 2 times 1, so that's simply equals to 2. So we can here say that 2 and 1 are the factors. So 2 and 1 are the factors of 2. So using these two factors, 2 and 1, we can rewrite 3. So 3 can be also expressed as 2 plus 1, where 2 and 1 are the factors which we have obtained by multiplying the coefficient of x raised to the power of 4, which is 2, and the constant term, that is 1. Fine, x squared plus 1. So this is going to give us 2 times x raised to the power of 4 plus 2x squared plus x squared plus 1. Now we have 4 terms. So from the first 2 terms, we can take 2 times x raised to the power of 2 as the common factor. So this will get multiplied to x squared plus 1. Added to, so from the third and the fourth term, we can take 1 as the common factor. So the 1 will be multiplied to x squared plus 1. Now we are left with 2 terms. Now from each of the 2 terms, we can pull out x squared plus 1. So this is going to be the common factor, which will be multiplied to 2x squared plus 1. So this is these two are the factors of 2 times x raised to the power of 4 plus tx squared plus 1. Meaning, we can rewrite our rational fraction x squared plus x plus 1 whole divided by 2 times x raised to the power of 4 plus 3x squared plus 1. So this can be also expressed as x squared plus x plus 1 whole divided by, now the denominator will be x squared plus 1 times 2x squared plus 1. Fine. So what we have done, we have just factorized our denominator, but immediately we can say here that we can resolve this particular rational fraction into 2 partial fractions. So the first partial fraction will come to the numerator in a moment. The denominator will be something over x squared plus 1, and the other partial fraction will be something over 2x squared plus 1. So we are getting 2 partial fraction. Now for the partial fraction with denominator x squared plus 1, now clearly x squared plus 1 is a quadratic factor. So that means our numerator should be of the form ax plus b. Similarly for the second partial fraction, since our denominator is a quadratic form, so our numerator is going to be cx plus d. So this is how we can resolve a given rational fraction into this constituent partial fraction. So here we have 2 partial fractions, and our goal will be to determine the value of a, b, c, and d. Now what we'll do, we're going to label this as number 1. Now in the first step, what we'll do, we'll take equation number 1. So we'll only take this 2 part. We're going to multiply both sides with the denominator, which is x squared plus 1 times 2x squared plus 1. So let's multiply each side with the denominator, x squared plus 1 times 2x squared plus 1, such that we now get x squared plus x plus 1. So that's the expression on the left hand side. On the right hand side, we have 2x squared plus 1 multiplied to ax plus b. Here x squared plus 1 gets factored out. This will be added to x squared plus 1 multiplied to cx plus d. Fine. So what we'll do next, we will expand the expression on the left hand side. So here we have x squared plus x plus 1. This will be equals to, so the highest part of x on the right hand side will be x cubed. So x cubed will going to have a coefficient 2a plus c, followed by the next lower highest power, so that's going to be x squared. So its coefficient is going to be 2b plus d. Then we have the next term which contains x, so x is going to have a coefficient a plus c. And then finally we are going to have the constant term, so that's going to be b plus d. So here on the right hand side we observe that there are 4 terms. The first term contains x cubed, second term contains x squared, third term contains x, and the fourth term contains only the constant term b plus d. Now on the left hand side we have only 3 terms. Now there's a term which does not contain x cubed, so that term is missing, but we can rewrite it as 0 times x cubed. This is done so that we can compare both sides or equate both sides, and this is going to give us 4 equations. The first equation being 2a plus c equals to 0. So here we have equated the coefficient of x cubed on both sides. Then we have 2b plus d, so that's going to be the coefficient of x squared on the right hand side. This is simply going to be equals to 1 because we have x squared present on the left hand side. Next we have a plus c, so that's also going to be equals to 1. And we have b plus d, so that's going to be equals to 1. So now what we have here are 4 equations and we have 4 unknowns a, b, c and d, so we can easily obtain its value. So let's do that. What we can do here, we can rewrite 2a plus c as a plus c. That will be equals to 0. Now we have already mentioned here that a plus c, that's equals to 1. So we have a plus, we're going to replace this a plus c with 1. So we have a plus 1 equals to 0. Solving for a, we get a equals to negative 1. Now that we have the value of a, we can replace this to get the value of c. So I have negative 1 plus c equals to positive 1. So c value comes out to be 2. Fine. Then we have 2b plus d equals to 1. This can be expressed as b plus d equals to 1. b plus d, we have the value that's equals to 1. So where b plus 1 equals to 1. So b becomes equals to 0. If b is equals to 0, we can replace it here, and that's going to give us the value of d. So d value comes out to be 1. So we have successfully obtained all the values. So a is negative 1, b is 0, c is 2, and d equals to 1. We'll replace all this value back in this number 1, and this is going to give us the required result. So let's do that. So here we have the value of a, so that's negative 1. So we have negative 1 times x plus 0 divided by x squared plus 1 plus cx, so c is 2, so we have 2x plus d value is 1 divided by 2x squared plus 1. So finally what we'll do, we have obtained the partial fraction, so x squared plus x plus 1 divided by 2x raised to the power of 4 plus 3x squared plus 1. So that will be equivalent to 2x plus 1 divided by 2x squared plus 1 minus x divided by x squared plus 1. So this is how we have successfully resolved the given rational fraction into 2 partial fractions.